to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. Today we are going to be learning about Math Kangaroo tips and strategies, and we are going to be looking at general rules, scoring, tips and strategies, and at the end there will be a lot of practice problems. So this is particularly for levels 5 and 6. Now, while talking about the general rules, let's first introduce what Math Kangaroo is. So it's a national-wide mathematical test, and there is 30 questions for this particular level. I think for many other levels there are also 30 questions. And it is a multiple choice test, so you have the option of eliminating other options and finding the correct answer. So it is a 75-minute test, so you have 1 hour and 15 minutes to finish the test, and you're not allowed to use any calculators, phones, no extra devices to help you. So let's start on the strategies and how to perform the Math Kangaroo test correctly. So now, before we look at the actual strategies on performing the test and looking at problems from previous years, we're going to introduce the scoring on how the Math Kangaroo kind of works. So for the point value, each third of the test will be worth 3 points, 4 points, and 5 points. So the first third of the test, which is 10 problems, will be 3 points, and this is the easiest out of the whole test. The next would be 4 points, not as easy as 3 points, and 5 points will be way difficult. So this would be 10 problems for 3 points, 10 for 4 points, and 10 for 5 points. So the maximum amount of points that you can get is 120 points. And if you get 120 out of 120, you're really smart. So the top 20 will be placed on a national winners list, and you'll get a certificate and many more. So on how the scoring and how the ranking works, so if a bunch of people get 100%, you'll all be recognized as first place, but if you get like a 99 or less than that, it'll be based on what score you got and so on. And you will be given a percentile, or your parents will be given a percentile, which means the percentage of the people who got a lower score than you, so that will be given, and I think your ranking as well. So this is how the scoring works for the Math Kangaroo. Now let's get to the fun part, the strategies and looking at previous problems of previous years. So here are some tips and strategies that you can use when taking the Math Kangaroo test. The first one is visual and spherical cues. This basically means pictures. More than 3/4 of the test is going to be based on pictures, and later in the test the pictures are going to get harder and harder. You can simply solve problems with pictures on them using the pictures, the problem itself, and some of your mathematical skills. Let's look at a sample. If we have 3 objects as shown below, what do we see if they look at them from above? So as you can see, we can see them in a side view, and here are the 5 options. To solve this problem, what you're going to do is you're going to change the way that you look at them, your visual perspective of the picture. Right now you're looking at it sideways, so when we look at it up, the picture will look as above. So obviously you're going to have the rectangle here and the square thing here. Now, in most of the problems, this has this accurately, but the position of the circle is where the options vary. You can see that this is right along the middle of the side length of the rectangle. So this is how it's supposed to look like. Which option matches this? Well, when we see, we get C, and that is the answer. So this is how you can use your visual perspective and your mathematical skills to solve problems with pictures on them. So one of the main strategies in Math Kangaroo is knowing how to analyze pictures and use them to solve the problem. For example, let's say you have a problem like this. You have to find the measure of this. You're not going to actually measure it using a compass. Obviously you can't, because you're not going to be allowed to use a protractor or compass. But what you're going to do is you're going to use your mathematical skills, and most likely there's going to be other numbers there to help you solve. So that's going to be how you're supposed to solve it. So now we have a problem with a picture in it that we're going to need to use to solve the problem. Let's read it out loud. So the drawing shows 3 flying arrows and 9 balloons that do not move. When an arrow hits a balloon, the balloon pops and the arrow fires farther in the same direction. How many balloons will not be hit by arrows? First of all, notice that not is underlined. You have to make sure to read the problem carefully when you're doing it. Most people get confused when it says how many balloons will not be hit by the arrows. They just skip the not and say how many balloons will be hit by arrows. So make sure to always watch out for that. So it says that when an arrow is fired, when an arrow is fired, it's going to, when it pops, regardless of when it pops, it's going to keep on going in the same direction. So when an arrow fires, we're going to assume that it goes through this whole line, and this whole line. So in doing that, let's see how many balloons we can eliminate to find the ones that are not popped, because that's what it says. So let's put a line through here, and a line through here. So the arrow has been fired throughout the line. Now let's see how many balloons are eliminated. Well, this one's hit, so this balloon is gone. This one's also gone. And for this one, this is gone, this is gone, this is gone, and this is gone. So how many is left? Well, count. 1, 2, and 3. So only 3 balloons are left. So the answer is A, 3. Another tip or strategy that's useful when taking the Math Kangaroo is the use of analytical and algebraic approach. This means when there's a normal problem or a picture with missing variables in it, you put it into algebraic form or use equations or system of linear equations in which you can solve easily by solving for the missing variable. In this case, let's look at a sample problem that addresses all of that. The sum of the ages of Kate and her mother is 36, and the sum of the ages of her mother and Granny is 81. How old was her Granny when Kate was born? Now we have a problem that's in words. Now what we need to do is put it into algebraic form and write it as a sum or equation. Now we know that the sum of the ages of Kate and her mother is 36. So let's write Kate as K. Or you can just write Kate. But Kate plus her mother, which is N, is equal to 36. And we also know that the sum of the ages of her mother and Granny, so M for mother and G for Granny, is 81. Now what we can do here is use the elimination process in which we can turn this whole thing into a negative by multiplying by -1. When we do this, this becomes negative M minus K. All I did was switch the order of M and K since this is positive for now. And we get negative M minus K is equal to negative 36. Now we have it in the vertical form. So M minus M is 0. So we're just going to write that. And then you have G minus K is equal to 81 minus 36. And you can just simply do that here and you get 45. So Granny minus Kate is equal to 45. Since we're finding out how old was Granny when Kate was born, what we need to do is find the difference of their ages. So when Kate was 0 years old, Granny must have been 45. Since when you subtract Granny's age by Kate's age, you get 45. So the answer is C, 45. So let's do another problem that involves algebraical approach. Here's the second problem. So there's 3 squares, although it might not seem like they're squares, they are squares, and the side length of the small square is 6 centimeters. What is the side length of the biggest square? So we know that this length right here is 2 centimeters, so this is going to help. If we know that this is 6 centimeters and this is 2 centimeters, we know that this in total is 8 centimeters. And since it is a square, all side lengths are the same. So this is also 8 centimeters. For this, since this is 6 centimeters, this whole side over here is also 6 centimeters. And since we're trying to find the length of this thing right here, it's saying that this is 8 and this is 6, and we have 2 extra right here. So it's going to be 8 plus 6 minus 2. The reason why is because this side length is this whole thing minus this segment right here. And we know this segment is 2. So the whole thing is 8 plus 6. So this represents the whole thing minus the part of this segment. So the whole thing is 14 minus 2 is 12. And this, since this is 12, then since it's a square, obviously, this is also going to be 12. So the side length of the biggest square is 12. C. Now let's look at another sample problem from Math Kangaroo, grades 5 through 6. The problem is, Alice subtracted 2-digit numbers. Then she painted 2 shells. What is the sum of the 2 digits in the painted shells? So these two are the painted shells. So to find out what number these two are, let's first put it into this form. So a number minus 20 something is equal to 25. Now let's start from the left. We know that 3 minus something can't equal to 5. So let's borrow a 10. And when we do, we get 13. 13 minus what is equal to 5? That's 8. Knowing that 28 is the second number, we can use addition to find this number over here. So 28 plus 25 should equal this number over here. So we can do 28 plus 25. Now 28 plus 25, 8 plus 5 is 13. Add the 1 over here, and we get 53. So the number over here would be 53. However, it's asking for the sum of the two painted shells. So over here, the number would be 5, and over here, the number would be 8. So 5 plus 8 is equal to 13. So the answer would be D. Let's look at 2 more practice problems. How many times do we have to roll a regular dice to be sure that at least one result will be repeated? Options A, 5, B, 6, C, 7, D, 12, and E, 18. Now we know that a regular dice has 6 sides. So in the worst possible case, each side could come on each of the rolls. So there would be a different side on each of the rolls. So since we're looking at the worst possible case, there would be 6 rolls for each of the sides. Now for one side to be repeated, you just need to add one more roll for at least one side to be repeated. So that would be 7 rolls. So the answer is C7. You could also do this by elimination, by eliminating A and B, but I feel like this is easier. The second problem. The sum of any two numbers with a common edge must be the same. What is the sum of all the numbers in the triangle? Now, let's assign a variable for some of the sides that we don't know. For example, this one, and let's say this one. Now, we know that 2 and y have the same answer, and x plus y is also the same. So if we subtract y from both sides, you get that x is equal to 2. So this can be substituted with a 2. Now, 2 plus 3 is equal to 5. So the sum of this is equal to 5. So for every sum, the number has to equal to 5. This is 5. 2 plus 3 is equal to 5. So 2 plus y must also be equal to 5. So when we do that, we get y is equal to 3. So the sum must be equal to 5. So this is 2, 3, 2, 2, and 2. Now we just have to add all of this. So that would be 2 plus 3 plus 2 plus 2 plus 2 plus 3 plus 2 plus 2 plus 2 plus 3 plus 2 plus 3 plus 2. Let's just count whether we got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. So 2 plus 3 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 3 is 14. 14 plus 2 is 16. 16 plus 3 is 19. And 19 plus 2 is 21. So the sum of all of these is 21, which is option C, 21. So for both of these, the answer is C. One strategy that you can use when taking the Math Kangaroo test is the analytical and graphical approach. This is when, if you have a problem and a picture, what you're going to do is break down the problem and the picture into simpler steps and solve in the simplest way possible. Let's look at a way where this is live in action. Sample problem. A garden is divided into identical 1 meter by 1 meter squares. A fast snail and a slow snail move along the perimeter of the garden, starting from point S, but in different ways. The slow snail moves this way in the speed of 1 meter per hour, and the fast snail moves this way by 2 meters per hour. At what point will the two snails meet? So we know that we start from here, and the fast snail, both of them start from here. So let's use this color to use the fast snail, show how the fast snail is moving, and black to show how the slow snail is moving. Instead of actually finding the perimeter and finding where they meet, let's do it in the simplest way possible, which is actually doing it out. Now, when using this, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's stop right here. 4, 5, 6, 7, 8, 9, 10, and 11, 12. Now, let's do it this way. Now, 2 of them are going to be 1 unit for this snail. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just stop right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, when you watch where it meets, then you get 1, 2, 3, 4, 5, 6, 7, and 8. 8 is where they meet at point B. And let's look at this now. 1, 2, 3, 4, 5, 6, 7, 8. It's also 8 steps when it meets at B. So the point where it meets after point S is point B. And you can do this by directly doing it on the problem instead of using your algebraic skills. This is another way of doing the problem. Let's do another problem involving analytical and graphical approach. A star is made of 4 equilateral triangles and 1 square. The perimeter of the square is 36 centimeters. What is the perimeter of the star? So we know that the perimeter of the square is 36 centimeters, meaning the sum of all of the sides is 36 centimeters. And since all the sides in the square are the same, this side, this side, this side, and this side are all congruent. So the side of 1 is 36 divided by 4, which is 9. So each side is 9 centimeters. Now we also know that 4 of the triangles outside are equilateral triangles, meaning that all the sides are the same. So this is 9, 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 9, 9, and 9. Now perimeter means the sum of all of the side lengths, and we know that there's 9, 9. Now let's just erase all the stuff that we don't need. Now for perimeter, it's just the outside, so we don't need the side lengths of the square, it's just the outside. And when we add all that up, we get 9 plus 9 plus 9 plus 9 plus 9 plus 9 plus 9. So there should be 4 sets of 9 plus 9. And you get 18, and since there's 4 of them, it's 18 times 4, which is 72. So the perimeter of the star overall is E72. So most of the Math Kangaroo problems involve geometry, a concept that you need to be familiar with, mainly the shapes, because in many of the picture problems, the problems involving pictures, they will have problems involving ratio between different colors in shapes such as squares, rectangles, and so on. In a problem like this, it says, in which of the 4 squares is the ratio from black to white the largest? So the shaded region is black. Now how we're going to solve this is we're going to convert these shapes into models like this, in which each of them have 16 equal parts, 4 in each of the mini squares. So we're going to convert A into that first. So as you can see, each of these, you can still see the 4 individual shapes. 1 full square is covered. So this is 4 by 16 ratio for the first square. And we know 4 by 16 is just 1 over 4. Now let's see if there's any better ratio over here. Now for B, it has the same type of ratio. So let's just draw this model right over here. So we have this and this. Now out of all the squares, only 1, 2, 3, 4. 4 out of 16 are shaded. Same answer as we got for A. Now for C and D. Now C has these 2 shaded right here. So we're going to do the same thing that it shows here. So it's the same thing, except we just added extra lines, as you can see. It's the same exact model for each of them. Now in this one, 1, 2, 3, 4. 4 parts are shaded again. So it's 1 over 4. So by far, all of these have the same ratio from black to white. Now let's see if D has any difference. So D looks like this right here. So we're going to copy this over here. So it looks like this, and again, there's only 4 parts that are colored. 1, 2, 3, 4. So it's 4 by 16, which is again 1/4. So no square has a bigger ratio of black to white. All of them have the same, which is 1/4. So one of the whole parts are shaded when you put them into models like this. So you can kind of see when we find the answer, we're going to kind of split the square into more parts, so it's easier to compare. So this is how you do it when there's geometric problems. So when you find you get all of the ratios are the same, so the answer is E, all the same. Sometimes when doing math Kangaroo, you just have to follow the narrative, which means you need to, when you're doing a problem, you just need to follow the narrative and draw the pictures out to help you. Knowing that, let's do an example. Write 0 or 1 in each cell of the 5 times 5 table so that each 2 times 2 square has 3 equal numbers. What is the largest sum of all the numbers in the table? So using this tip, let's go ahead and use this table that is given to us to draw the numbers out. So we know that in each 2 times 2 square, which is 2 times 2 squared, we need to have 3 equal numbers, which means 3 1s and 1 0, or 3 zeros and 1 1. Now, since we're finding the largest sum, it would be better to use the larger number 3 times. So we have to use 1 3 times in each 2 times 2 square. So knowing that, let's do 3 1s in this 2 times 2 square and 1 0. And you're going to repeat doing that for all the others. So over here, in another 2 times 2 square, we have 3 1s and 1 0. And you do that for all of the 2 times 2 squares here. 3 1s and 1 0. And over here, 3 1s and 1 0. Now, if you just add a 1 in for the rest of them, you'll find that it will automatically have 3 1s and 1 0 over here. If we just add 1s for all of them over here, you will notice that this 2 times 2 square has 3 1s and 1 0, 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 and so on. So after we have all of this done, all we need to do is find the sum of all of this. So if we add it up, we get that it's B21, which is the answer. So when you have problems like this, make sure to always draw it out and use the table given to you. Now let's look at another problem based on following the narrative. Let's read this example. 9 cars arrive at an intersection and drive off as escalated, which means the direction. Which figure shows the cars after they leave the intersection? So over here, we have to use this drawing and figure out which cars go where, and use the options to find the answer. So we can use the directions as indicated and cross them off to make it. So over here, we are using the tip and using the pictures drawn out. So over here, let's start off here. So in this car, the direction is going down here. So we would have a small car over here, and we can cross this. And over here, this car is going towards this direction. So we can make a small car here and cross this one. And over here, this car is going this direction. So we can make a small car here, cross it. And over here, this car is going straight. So we can cross it. And this car is also going straight. So we make it over here. And this car is going this direction. So put this over here, cross it. And this car is going over here. And we cross it. And we have this car over here, going this direction, and one car over here. So when we look at the options, there's a car here, 4 cars here, and 3 cars here. And that would be option B, since there's 1 car here, 1 car here, 4 cars here, and 3 cars here. So in these types of problems, you need to use the drawing and cross out or use whatever's there to find the answer.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramagic.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically basically the end of the email, but without the info and the end. So bye!